In this video, we're going to talk about how to find the number of protons, neutrons, and electrons in each of these atoms. Before we do that, it's important to understand how we find the number of protons, neutrons, and electrons. It's very basic. Protons are equal to the atomic number. So if you're looking at the periodic table, the atomic number is the number at the top of the box. It is always a whole number. And so for hydrogen, it would be 1. For helium, 2. For lithium, 3. You get the picture. It's the whole number at the top of the box. Electrons are equal to protons. They are equal to the number of protons. However, it's not always true unless it's an ion, unless the element is an ion. And then neutrons, and we'll talk about how to recognize an ion in just a minute. Neutrons are equal to the atomic mass of the element, the mass, minus the atomic number. So the atomic mass would also come from the periodic table. It would be the sometimes decimal number, or sometimes whole number, mostly decimal number, at the bottom of the box, underneath the symbol and name of the element. So for our first element, lithium, if you were looking at the periodic table, you would see the atomic number 3, the symbol Li, and underneath you'd have a decimal number, 6.941. The top number 3 is the atomic number of lithium, and recall that the atomic number is equal to the number of protons. So there are 3 protons in lithium. Since lithium isn't an ion, and we know it's not an ion because it does not carry a charge, there are 3 electrons as well. Remember that protons are equal to the number of electrons. Now, the neutrons. The atomic mass for lithium is 6.941. When you get ready to do these, I want you to round that atomic mass up or down. You cannot have a decimal number of neutrons as your answer. For this one, you couldn't obviously have had 3.941 neutrons. That wouldn't make sense. You can't have 0.94 of a neutron. So we round the mass. And in this case, we can round 6.9 up to 7. And so we would do the mass of 7 minus the atomic number of 3 is equal to 4. So lithium would have 4 neutrons, 3 protons, and 3 electrons. Now let's go to number 2, Ca2+. This carries a charge. 2+ is a positive charge. What that tells us is that this atom is an ion. That means that it has lost electrons, specifically 2 of them. If it carries a positive charge, it loses electrons, and if it carries a negative charge as an ion, it has gained electrons. You'll see a negative ion in the next one we do. So for calcium to be 2+, that means it has had to have lost 2 electrons. So in our final answer, we should have 2 more protons than we have electrons, which would make sense because protons are positively charged, and it's a 2+ charge, so there should be 2 more protons than we have electrons. So we look at the periodic table and we find calcium's atomic number. Calcium, Ca, has an atomic number of 20 and a mass of right at 40. It looks like it's 40.1 if we were to round it. And so the proton number is equal to the atomic number, which is 20. The neutrons are pretty straightforward here, so let's just get those out of the way. The mass of calcium is 40, and we subtract the atomic number 20. So it has 20 neutrons as well. The electrons, though, are a bit different here. Remember, if it's 2+, that means we have lost 2 electrons. In a traditional atom, the electrons and protons should be equal. So if this were not an ion, we would have 20 electrons, but it has lost 2 electrons because it has a 2+ charge. So there should be 2 more protons than we have electrons. So that means we would have 18 electrons in this atom. Now, let's do the next one, number 3. Nitrogen 3-. Nitrogen 3- also tells us that this is an ion. That 3- charge means that the nitrogen atom has gained 3 electrons. So in this case, we should have 3 more electrons than we have protons. So if we're looking at nitrogen on the periodic table, you would have the symbol N, you would have the atomic number 7, and then you would have a mass of 14. And so the protons, remember, are equal to the atomic number, so there'd be 7 protons. Neutrons come from the mass, which is 14, minus the atomic number 7, so there would be a total of 7 neutrons in nitrogen. And electrons, this is an ion. It has gained 3 electrons. And so it should have 3 more electrons than it does protons, and so there would be 10 electrons in this atom. The last one, 4, phosphorus hyphen 32. When it has a hyphen 32 like this 32 right here is the mass of the atom. Typically, when you encounter an isotope or an atom that has a different number of neutrons, you write the mass after the hyphen in the name like this. And so 32 is telling us the mass. So when we go to calculate the number of neutrons for phosphorus hyphen 32, we are not going to look at the periodic table for the mass. We are just simply going to use the mass from the question. So the mass would be 32 for this one. So first, let's get the number of protons. If you're looking at the periodic table, phosphorus has an atomic number of 15. I'm out of space, so I'm not going to draw the box like we have in the past, but at the top of the box, above P, you would see the number 15. That's how many protons phosphorus has. It's the atomic number. The electrons, this isn't an ion, there's nothing charged here. We didn't have a charge of any sort, and so the electrons are equal to the protons, 15. Now, phosphorus here has a mass of 32. And we're using this mass once again because it was written in isotope form that this phosphorus atom has a mass of 32, making it an isotope. I know it is different from the mass on the periodic table. You would see a mass of roughly 31 on the periodic table. So this phosphorus atom would have 1 more than the average phosphorus isotope. So we have a mass of 32, and we subtract off the atomic number of 15. And so the number of neutrons would be equal to 17. It would be 17 neutrons. So I know this has been a bit confusing talking about ions and isotopes and calculating the protons, neutrons, and electrons for each one. I hope that this video kind of provides a sense of clarity to that for your test tomorrow.